All right, 21. The fastest measured pitch baseball left the pitcher's hand at a speed of 45 meters per second. Okay, so we're throwing a baseball here. Okay. Baseball. Okay. Throwing a baseball. And the fastest it left his hand, which is what? Is that right? Soon as it comes out of your hand, right there, initial velocity, right? You play baseball, don't you? So you know what I'm talking about. Does that make sense? Okay. Not 3 seconds down the road, just as he releases it. I mean, just that quick, okay? All right. All right. If the pitcher was in contact with the ball over a distance of 1.5 meters, so in other words, let's just say from here to here, because, you know, he's gonna pull it back, right? So from back here to right here, and I've exaggerated that distance there of the ball coming out of his hand. Okay, it's just coming out of his hand. You understand? All right. So that delta X is what? 1.5 meters? Okay. All right. And produce constant acceleration. So what do I need to write up here? I need to say acceleration is equal to constant. Okay. All right. What acceleration did he give the ball, and how much time did it take him to pitch it? Okay. All right. So, which of the kinematics would be our best equation? Okay. It says, what is the acceleration? Okay, so wait a minute. What acceleration did he give the ball? So acceleration is constant, so therefore we want to know how much he gave it, right? Would this one work? And solve for A. Would that work? Okay. All right, now. And I labeled something wrong, didn't I? Right? And you say, how do you know that? All right, watch. When it comes out of my hand, all right, is there anything else acting on the ball? Other than gravity, yes. Air resistance, minimal, okay, a little bit. But it's negligible. So actually I shouldn't have labeled that initial velocity. I should have labeled it what? Final velocity. So its initial velocity is what? 0, just before I release it. Because final velocity, when it comes out of my hand, is there anything else pushing it to give it any more velocity? No. Now I know there's drag and stuff, gravity, but gravity doesn't slow it down in the x direction. Okay, it doesn't slow it down. We're going to talk about this in chapter 3. It doesn't slow it down in the x direction. Now air, yeah, a little bit, but again, it's negligible with these short distances, okay? Now, yeah, a mile downrange, 2 miles downrange, 3 miles downrange, shooting a rifle, shooting an artillery shell 20 miles, yeah, it's going to slow it down, okay? Because it's passing through a lot more air. You got different wind speeds, sure, okay. All right, so look, we can find it now. All right, so the velocity final is 45 meters per second squared plus 0 squared over 2 times what? 1.5 meters. And you should get what? 675 meters per second squared. Does that sound right? Should. Okay, now part B is what? B says what? How long did it take to pitch it? All right, we know final, we know initial, we know the acceleration. Well, that's the problem, though. Let's see. Vs. All right. Let's see. Would that work? Yeah, I think that one would work. Yeah. What would that be? No. We don't have displacement. We don't have displacement in that equation. What about this one right here? And solve for t. And when you solve for t, what do you get? You get 2 times delta x. Look, carry that back across. That becomes delta x. Okay? Over what? V initial plus V final. So we got 2 times 1.5 meters over what? 45 meters per second. And we get a time of 0.067 seconds. Right? And you say, Mr. Shields, why did you use that one? Because you have displacement. Okay? You have to use it. Okay? All right, any questions? I hope I started that video back. Yeah, I did. Good. All right.